In example 4, they're asking us to use an experimental probability to make a prediction about the number of items in a bag. So they're telling us in this particular problem that a bag contains 50 marbles. We randomly draw a marble from the bag, record its color, and then replace it. The table shows the results after 30 draws. They're asking us to predict the number of red marbles in the bag. So I'm going to click over to the camera here. And right here, they tell us that we pulled 30 draws 30 times, and blue came out 3 times, green 12, red 9, and yellow 6 times. Based on that fact, they're asking us to predict or guess how many red marbles are in the bag. So red came up 9 times out of 30, and that is called the experimental probability, 9 out of 30 pulls. When I simplify that, we get 3/10. So that's the actual number of times red came out of every 10 pulls. So based off of that, if we take our experimental probability and multiply it by the total number of marbles that are in the bag, it gives us a pretty good estimate as to how many red marbles are in the bag. And we can actually do this for any of the 4 colors, but they're only asking us for red right now. So I'm multiplying by 50, and I can imagine it as a fraction over 1. And I can cross cancel here out at 10, multiply straight across, and I get 15. Excuse me, 15 red marbles in the bag. That doesn't mean there are 15 red marbles. That's based on the fact that it came out 9 times when we pulled 30 tries. So if I were to guess how many blue marbles were in the bag, I would probably guess less than 15 because it only came up 3 out of 30 pulls. So there's probably way less blue marbles in the bag than there are red, just based on the amount of times it actually happened. So that's how we can use experimental probability to help us predict how many items of a certain color or size or whatever are in a bag.